Sri Sai Ram. Hearty welcome to Sri Sathya Loka Seva Gurukulam, secondary course NIOS. Chapter is motion and its description. We are coming to the last part of this lesson. I think you enjoyed the previous lessons about motion. There is no matter in this universe without motion. Even the rocks also, hillocks also, they are also in motion. So we have seen every day, of course, from morning till night, even if after sleeping also, we find motion. Our breathing is a motion, is it not? Eyes seeing things is a motion, and while talking, the movement of the tongue is also a motion, and blood is in continuous motion in our body. Whole universe is in motion. And we have seen in the previous class that there are three kinds of motion. Rectilinear means going in a straight line, circular going in a circle form, and oscillatory. And there are some motion which have no discipline or no control, like tsunami, hurricane, etc. Is it not? So they are irregular motions. And also you have studied about speed and velocity, rate of change of position or rate of change of distance travelled is called as speed. The formula for speed is S is equal to d by t, where d stands for distance travelled, t stands for time. Velocity is the rate of change of displacement, that is distance travelled, but this is displacement. Both have the same unit. The unit is meter per second, it is a unit. And I also studied about acceleration and retardation. Rate of change of velocity is called as acceleration. Retardation is negative acceleration. Other day we discussed the example of a train. Train starting from a station, go on increasing speed, is it not? That is called acceleration. And when it approaches the next station, the speed go on decreasing, that is retardation. So one is acceleration, another is retardation. And unit of measuring it is meter per second square, because it is rate of change of velocity, is it not? So it is a vector quantity. And also you have studied about the graphical representation of motion, what is called as position time graph, velocity time graph. So a graph is a representation of motion in an easier way. There will be two axes, horizontal axis and vertical axis, and time is taken usually on the horizontal axis, position on the y-axis. Similarly here time is taken on the x-axis, horizontal axis, velocity is taken on the vertical axis, and their graphs are to be drawn, which you already seen in the previous class. Now we will see some of the home assignment. First one, so the question is, the motion of an object is shown in the figure. Just now I was telling you about the graph here. This is a position time graph. This is position on the y-axis, time on the x-axis. This is in seconds. In 5 seconds, the body is at A. In 15 seconds, the body is at B. and about 20 seconds it is at C. So the question is, they explain the motion they are asking. So for first 5 seconds the object moves with the constant speed, that is 2 meters per second. So here from O to A it moves with a constant speed, that is 2 meters per second, because 10 by 5 distance by time, that is 2. So that will be a constant speed up to A. After coming to A, from 5 to 15 seconds it remains at rest. So 5 to 15, from here to here it is at rest, means there is no change in the position. As there is no change in the position, there is no changes also in the motion of the body. So we say the body is at rest from A to B, is it not? And then from 15 to 20 it moves with a constant speed of. So the motion of the object is not uniform. They are asked to explain what kind of motion it is. Okay. So from B to C, so here this is a constant speed, but from starting from O there is a change in the speed. So we don't, therefore we say it is not in constant speed. Speed go on changing. Here it is steady, here it is at rest, here again it is steady, like that. So there is change. So it is not uniform motion. So that is what we can make out by seeing the graph. And second question, compare the velocities of two objects. There are two objects here. One is called B, another is called A. So this is a position time graph. So this is position in meters, this is time in seconds. You are asked to compare the two motions. So velocity of A is 4 times the velocity of B. That is what you can say. So here this B, when the B reaches here in 5 seconds, this will be 20 seconds. So you have to extend it. So this will be 4 times. We can make out that the motion of A is 4 times the motion of B. That is we can make out, because actually it comes to a line of 20. So this is the line of 5. So we see that 20 is 4 times that of 5. That is how we can compare the two motions. When will you say a body is in uniform acceleration? So if the acceleration of an object during its motion is constant, we say that object is moving with the uniform acceleration. Other day I was giving an example of car going in a highway. So until it reaches highway, in the country road there will be bumps, humps and all, and the vehicle cannot go in a fixed speed, right? So when the velocity is not fixed, acceleration also is not fixed, not uniform. Once it reaches the highway, there is no other obstacles, is it not? So there will be same velocity will be there. When the velocity is same, acceleration also becomes uniform. So on the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. So car going in a country road is a non-uniform. Starting to be 0, it picks up say 10, 20, 30 like that. Sometimes it may go up to 60. Next time it comes to 0. And in villages, you have seen, even if you're going a two-wheeler, so many obstacles. There will be suddenly a dog will come in the middle of the road, or a sheep will come. Some children also comes. So lot of obstacles. Then you have to put brakes. When you put a brake, there will be impediment in the speed, right? So it is not uniform. Then we say it is a non-uniform. Uniform means rate of change of velocity becomes same. Non-uniform means the velocity changing according to time. So that is, non-uniform acceleration is when there is a non-uniform acceleration, means the rate of change of velocity changes, then you have non-uniform acceleration, or you can say the body is moving in a non-uniform rate. At one time it may go very fast, another time it may go a little slow, very slow. Sometimes you have to stop also, isn't it? So all this we see, and that is a third question of home assignment given to you. Fourth assignment, during an experiment a signal from spaceship. What is spaceship? Something like a satellite, and there are so many things like that. So reached the ground station in 5 minutes. It's a very beautiful experience. Can you name some of the spaceships? First satellite launched by India was Aryabhata. Why it is called so? It is named after a scientist, Aryabhata. Then named after Bhaskara, you have Bhaskara, then Rohini, etc., etc. And INSAT series. All these are the INSAT series. All these are some of the satellites launched by our great country India by the help of rockets. So when they come down, they send the signals. So here is a spaceship which is coming down, and it has sent a signal 5 minutes that we are approaching the earth. It is a very thrilling experience. You must see a CD actually, on which all of you can get it very easily. There is a CD in which Neil Armstrong, was Neil Armstrong? The first man landed on the moon. He is from USA, he is a devotee of Swami. So when he kept his first foot on moon, it was a very thrilling experience. The scientists start shedding tears. Why tears? Tears of joy. And they felt very happy. So when he was coming back, they sent signals. So here is one spaceship, signal was sent in 5 minutes. What was the distance of the spaceship from the ground station? So it reached in 5 minutes that we are coming. And how does it fall? It falls to the ocean. There will be some ships waiting. It falls onto the ship. Then they will be taken in the boats. Is it not? So what is the distance they are asking? And signal travels the speed of light. Speed of light is 10 to the power of 8 meter per second, or 3 lakh kilometer per second. So distance of the spaceship is equal to velocity into time. Time is 5 minutes. So if you convert that 5 minutes, it becomes 5 into 60 seconds. Velocity of light is 3 into 10 to the power of 8 meters. So 3 into 10 to the power of 8. Don't think it is a very small unit. 10 to the power of 8 means what? There will be 8 zeros. Okay. So 3 into 5, 15 into 6, 90. So 3 5s are 15. 15 into 5 is 15 into 6 is 90. So 90, 900. So we write it as 10 to the power of 10, because there will be 2 more zeros adding. So 9 into 10 to the power of 8, 10 meters, or 1 kilometer equal how many meters? 1 kilometer is equal to how many? 1000. Okay, kilo means 1000. So you can write it also as 9 into the power of 7 kilometers. Is it not? So means there will be 7 zeros. 9 followed by 7 zeros. So much of kilometers of distance. The spaceship is there. It is approaching fast, and the signal will be sent to the earth. Okay. How many of you want to go to space in later date, not now? Now you are in class 9th or 10th. So in later date you will reach the space. If you are interested, you can try. Okay. So you might have heard about Kalpana Chawla. She is a girl studying in Haryana, village girl. She was dreaming about going to space, and her dream in class 8th had made it fruitful for her travel to space. Okay. So this is the home assignment. Now for today's topic, we have equations of motion. It is world famous. Please bear it in mind strongly. Okay. What you have to remember? Consider an object with the uniform acceleration. We call it as A. Short form of acceleration, A. U be the initial velocity. V be the final velocity. And T is the time. S is the displacement. So acceleration becomes change in velocity by time. So change in velocity means what? It was u, it became v. So it became v minus u by time, v minus u by t. If you cross multiply, we get v is equal to u plus at. Is a very, very important formula. That is called first equation of motion. You repeat it 10 times. Write it in a paper. Okay. So what is v? V is final velocity. What is u? Initial velocity. What is a? Acceleration. What is t? Time. And how do you measure v? Measured in terms of meter per second. Velocity u also. A is measured in terms of meter per second square. T is measured in terms of seconds. Why I am telling the units is, while working out problems you must know how it is measured. Okay. So this is the first equation of motion. Please learn it perfectly. Then you have second, that is called formula for distance travelled, or you can say displacement. It can be got by getting average velocity into time. Average velocity u plus v by 2. U is the initial velocity, v is the final velocity. So average becomes u plus v by 2 into t. Because as you know the formula for displacement, S is equal to d by t. Is it not? So you have S is equal to d by t, the formula for the speed. So here it is average velocity. So what is the formula for V? U plus at by 2, because V is equal to U plus at. So instead of V we write U plus at. So there will be two U's. U plus U become 2U plus at by 2 into t. This t is brought here. Or shortly you can call it as S is equal to ut plus t into 2u become 2ut. At into t, at square. When you divide by 2, it becomes ut plus half at square. I think you are following. 2ut into 2ut by 2 plus at square by 2. What happens? 2 cancels. This is half at square. That is how you got the formula. S is equal to ut plus half at square. And here what is u? U is called initial velocity. What is S? Displacement or distance travelled, any one of the two. A is acceleration, t is the time. That is the second equation of motion. If the velocity starts from rest, u becomes 0 and S becomes 0 into t plus half at square. So if the body starts from rest, the formula is reduced to S is equal to half at square. Okay. So if you take A is equal to V minus U by T, already seen it, and then S is equal to U plus V by 2 into T, multiply the two, you get AS. So A and S to be multiplied. You multiply the left hand side, multiply the right hand side also. This is right hand side. So V plus U by 2, V minus U by T. So when you multiply these two, use the formula. What is the formula? A plus B, in algebra you have studied, A minus B is equal to A square minus B square. That is the formula. So you see, V plus U into V minus U becomes V squared minus U squared by t cancels, you get 2. Okay. So S is equal to U plus V, but this already we have seen it here. Again it's written, no problem. So this step is not needed. Okay. Then come to this. Now what happens now? 2 into AS become 2AS is equal to V squared minus U squared, or V squared is equal to U squared plus 2AS. This is the third equation of motion. So don't forget all the three very important formulas. First one is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. Third one is V squared is equal to U squared plus 2AS. These are called equations of motion. What is U? Initial velocity. What is V? Final velocity. What is A? Acceleration. What is T? Time taken. What is S? Distance travelled or displacement. So these are the three important. Why I am stressing is, you are supposed to learn it perfectly. Then only we can work out some problems. Now we shall see some problems. A body starts its motion with a speed of 10 meter per second. So U is equal to 10 meter per second. Accelerates into 10 seconds with 10 ms to the power of minus 2. 10 second time acceleration 10 meter to the power of 10 meters per second square. So apply it in the formula. Distance travelled or displacement, both are same. So here ut plus half at square. U means 10, 10 into t, 10 into 10, 100, plus half into a, 10, t square, 100. So 2 ones are 2 5s are. 5 into 100 is 500 plus 100 becomes 600 meters. Is it alright? That is the distance travelled. You can make out now. First you read the problem, see what are the things given, take a correct suitable formula. Here the question is distance travelled. So second formula you must take. So read what is asked, what is given you write, what is asked you find, use a suitable formula and get the answer, okay. Now coming to second type of problem. A car travelling in a straight line has a velocity of 5 meter per second. So u is 5 meter per second. At some instant, after 4 seconds his velocity changes to 8. So in 4 seconds, that is time taken t. Final velocity v. What is the acceleration? A is equal to v minus u by t, 8 minus 4 by 4, 8 minus 5 by 4, that is 3 by 4 or 0.75 meter per second square. So that is a acceleration. And what is the formula used? First formula, A is equal to v minus u by t. Very simple problem, is it not? What is u? Initial velocity. What is v? Final velocity. T is time, okay. Coming to third question. A ball is gently dropped from a height of 20 meters. If its velocity increases uniformly at the rate of 10 to the power of minus 2, with what velocity will it strike the ground? After what time will it strike the ground? So here there are two questions. So distance travelled, s is equal to 20 meters. Acceleration is 10 meter per second square. Formula is v is equal to u plus at. Why you want this formula? You are asked to find the timings. So 20 is equal to 0 plus 10 into t. So 10 into t is equal to 20, t is equal to 20 by 10, that is 2 seconds. Time taken is 2 seconds. So that is the answer for the one of the questions. At what time? Then next one is velocity they are asking. Initial velocity u is equal to 0. You are asked to find out final velocity. So u square is 0 square. 2 into a into s. So here 2 into a is acceleration, s is distance travelled. Is it not? So u square is 0 square, 0 only. 2 into a is 10. We have written here. Acceleration is 10 meter per second square. S is distance travelled, that is 20 meters. So you have 400. 2 into 2, 4, 0, 2 zeros. So v squared is 400. Velocity is the root of 400. It is 20 meter per second. Okay. So this is the third formula being used. So we have seen how it is applied in all the different situations. Okay. Now coming to circular motion. All of you know riding cycle. You know how to ride a cycle, right? That is the first thing you learn when you are very young also, from age say 3 to 4, start. See this guy, he riding on a cycle, right? You know all the parts of cycle, you don't want to explain, right? Here what we want to explain is the circular motion. The tires will give a circular motion and they move in a straight line in the road. what do you call it? Linear motion or rectilinear motion, and he is handling the brake there. So, circular motion. How many of you know the riding of the bicycle? You, by sitting only there only can sell. What are the experiences? Sometimes in the road, highways, you go very fast. Sometimes in a country road or a village road, you have to go very slow. And if bumps are there, you have to apply a brake and slowly you have to cross the bump. Suddenly, if a dog or a cat or a sheep comes in between, you have to apply brakes. Is it not? So, there are different situations and you have got a lot of experience in that. Sometimes you will be caught by police. In that, I remember one incident what Swami was telling. When a boy was going in a cycle and the traffic inspector stopped him because there was no light. It was evening, late in the evening, there was no light. So he stopped him and the road was little down after the signal and the boy was going very fast and policeman wanted to stop him, but he is not able to stop him. He came running and pulled him from backs. Why are you not stopping? He said, sir, there is no brake also for cycle. There is no light also, no brake also. Here Swami says, light means light of wisdom. One should have light of wisdom. What is wisdom? God is in me and same God is everywhere. Satyam, Jnanam, Anantam, Brahma. So that is the light. There is only one God. And what is the brake? Brake means control of senses. Whatever you want to see, you should not see because the lids are given to close it. Whatever you want to talk, you should not talk or eat also. The lids are given to mouth. So, they should have a proper brake, means sense control must be there. And also, you should have a light of wisdom. Then only life will be successful. Then only cycle, if you have proper brake and also light, then only the journey of the cycle will be successful. Because just imagine if there is no brake in the cycle, what happens? Either he may fall off, he may dash with somebody, so many things will happen. Is it not? And also in the evening times, if there is no light, means there are very dangers. Not only for himself, he creates dangers for others also. So, in our life also, we must develop wisdom and we should try to control our senses. What is good, what is bad, what is right, what is wrong, how to behave, how not to behave. Okay. Now coming to the topic here, uniform circular motion. This is about circular motion. So about bicycle we are talking about. It has got two motions here. A bicycle will go on the road, it is called rectilinear motion. And when it is going in the road, the wheels, they will be rotating fast. And that will be circular motion. So when you are not pedaling it, there is no circular motion of the flywheel and it moves in straight line. So when you are not pedaling means what? Where you don't pedal, if you are going in a down, then you not pedal, is it not? So there will be rectilinear motion, that is what you find, and the wheel will be in motion. So that is a position. And this is about a boy. So this is a very important part you must note. Chain, what you call. The chain snaps off, you find it very difficult to put the chain again. So this company is also very famous, rally company. This is a race cycle and the tires are also very strong here. I don't want to explain all those things. You also know, most of you know how to replace the parts and how to set it right and all. Okay. So during pedaling, its motion is circular motion because the wheels also rotate. So when the cycle is advancing in motion, there will be both circular motion and rectilinear motion. Rectilinear motion going in the road. Circular means rotation of the wheels. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Okay, one more thing, you can take one rope, say of 1 foot length. To the end of that, you tie one stone or one ball, metallic ball, and rotate it. You would have experienced it. So there you have circular motion, right? So there the finger becomes center and the thread becomes the radius, and in the end of the stone or the ball what you have, that becomes the object, and the rotation becomes circular motion. And if it is rotated with a suitable velocity, we call it as uniform circular motion. And here one more example, motion of an athlete running in a circular path is an accelerated motion. Usually not exactly circular, it is ellipse, means elongated circle. So the velocity go on increasing. When they say on the mark start, they will be at 0. Speed go on increasing, and when you come to the last finishing stage, it will be very fast. So here the formula V, speed of the athlete or in an object, will be given by the formula 2 pi r by t. How do you get 2 pi r? That is circumference. So distance travelled will be equal to the circumference of the circle. So circumference of the circle, that is given by the formula 2 pi r pi d. This is the radius r, and the body is moving in a circular motion. The total circumference is given by the formula c is equal to 2 pi r, also equal to pi into d. What is d? Diameter. So 2 radius is equal to 1 diameter. Okay. So distance travelled will be 2 pi r. Time taken is t. So distance by time becomes 2 pi r by d t. Okay. That is the formula for. So give an example. Here is a body called A and it goes to a point called B. So consider the motion of an object along a circular track of radius r, and through the 4 points A, B, C, D as shown in the figure. So this is radius r, the body is at A, comes to B, and then comes to C, comes to D. So what is the line stands for? They are called tangents at the different points. So a body is going in a circular path. Now let us see what happens. If the object completes each round of motion in same time, then covers equal distances in equal interval of time, and its motion will be uniform motion, also called as uniform circular motion. How it will happen? A body covers equal distance at equal intervals of time. Here speed remains constant. As there is a change in the direction of motion, there will be change in the velocity. So, speed remains the same, but velocity changes. Why does it change? Direction of the body moving, will be changing. See, here it is going like this, from right to left, here like this, or you can say, like this. The direction go on changing. Therefore, what changes? We say velocity changes. Velocity changes. And what remains? Speed remains the same. Speed remains the same. You might have heard about satellites. There are different kinds of satellites. One of them is what do you call it as geostationary satellites. There also speed remains the same and velocity changes because direction of motion changes. Okay, and in circular motion, if the speed remains the same, constant, the body moves in acceleration, change in velocity of the motion, and therefore you can note that even if the speed remains same, velocity changes because there is change in velocity, change in direction. Change in direction. Same experience you can see in case of a stone tied to a thread. Just now I have shown you, it rotates, describes a circular motion. You can also experiment from there. Suppose this is a thread. So this is a stone and this is your finger, the person who is catching. This is a radius, nothing but thread, length of the thread. So with the you tie a thread with a stone in one side, another side you have tie it to the finger and rotate it. That is a circular motion. Followed? And here also speed may remain same, but velocity changes because direction changes. Okay, so you can have so many examples like that. Let us see some of the home assignments. A car starts from rest and covers a distance of 50 meters in 10 seconds and 100 meters in next 10 seconds. What is the average speed of the car? A ball is thrown straight upwards with an initial velocity of 19.6 meters per second. It was caught at the same distance above the ground from which it was thrown. How high does the ball rise? A body accelerates from rest and attains a velocity of 10 meters per second in 5 seconds. What is the acceleration? So these are the three, and one more we will have. An artificial satellite, I was just now telling you. What do you mean artificial means what? Man-made. What is satellite? A heavenly body going around the planet, which is a natural satellite of Earth, Moon, is it not? So this is we are telling about artificial. This is artificial satellite. How to carry it to space? By the help of rockets. So moving in a circular orbit of radius 42,250 kilometers. Calculate its speed of it taken 24 hours to revolve around the earth. Use the formula V is equal to 2 pi r by t. Okay. So this is the homework you can think of, work out. Wish you all the best. Thank you.